Now, where is the difference?
नहीं नहीं, वो दूसरा देख रहा था। ठीक है सर, यही है, यही है।
यही था ना? Okay, यही था बेटे. Because beam simple, and so I can values I can see on the beam also. Okay, so we have taken this point x. It's a random point, any point. It could have been any other point also, no problems. I have taken a point 1 meter from D. Okay. Yesterday we were interested in the force. So what did we do? We took the resultant of force on either side, either left to right or right to left. Values came same. Today we are talking of bending moment. Okay. So we will do the same thing, but this time we'll do with the moments. So if I am interested in the bending moment at x, so how many forces are to the left of x? Guys, any of you do not understand, let me know, guys. To the left of x, I have two forces, Ra and 30 newtons. About x, now my question to you is, about x, is Ra going to cause a clockwise movement or anti-clockwise movement? About x, is Ra going
Clockwise.
to cause
Clockwise.
clockwise?
Clockwise.
Everybody agrees about x, this is the point. So it's about this, it will cause a clockwise movement. Yes or no, beta? Correct? So this 49 newtons will cause a clockwise movement about x, and that will be 49 into 3. Am I right? Because the lever will be 3 meters, 2 plus 1. Correct, guys? Yes or no? Am I right,
Yes,
guys?
sir.
Okay. And this 30 newtons will cause a 30 newtons will cause a anti-clockwise movement about x. So anti-clockwise 30 into 1. That means this is clockwise of 7 to 147. This is anti-clockwise of 30. The resultant is anti-clockwise 117 Newton meter. Yes or no, beta? Unit will be Newton meter. Why? You're multiplying force in newtons with lever in meters, so Newton meter. Do you agree that the forces to the left of x cause a bending moment of 117 Newton meter about x, which is acting in the clockwise direction? Do you agree with this, or any questions? Agreed, guys?
Yes, sir.
Okay. Likewise, we have two forces to the right of x. Let's take the moments of those about x. You can see 50 newtons about x will cause clockwise movement. So this will cause a clockwise movement of how much? 50 into 2, because now this lever will be 2 meters. So 50 into 2, that means 100 Newton meters clockwise. RB will cause anti-clockwise movement, and that is 31. So anti-clockwise of 31 into 5 plus 2, 7. That means anti-clockwise of 7217. Anti-clockwise 217, clockwise 100. The resultant becomes anti-clockwise 117. Yes or no, beta? Please check and let me know. Is it this from both sides? On both sides, its numerical value is
Yes,
117
sir.
Newton meters. But it is, if it is clockwise on one side, it is anti-clockwise on the other side. Yes or no, beta? Correct?
Yes, sir.
Correct, guys? Okay. Okay. Let's take the bending moment at
Sorry,
C.
sir.
Yeah,
Sorry,
tell
sir.
me.
One
Tell.
doubt, sir. So,
Yeah.
how come we subtracted 217 from 100, sir?
Because 100 is clockwise, 217 is anti-clockwise. The resultant will be the anti-clockwise 117. Yes or no, beta?
Right, sir. Then
217 is anti-clockwise, 100 is clockwise. So what will be the resultant of the two?
117. Okay, sir.
And that will
But
be 117
yes,
anti-clockwise, because 217 is more, right?
right, sir. Right, sir.
Okay.
And the left hand side, there
Yeah.
also, but it is opposite
Yeah.
moment, sir.
So that's why there the clockwise is more. So it is clockwise.
But
147
it
is clockwise on the left
but
side.
But we've added here.
We have added, is it? No, we have subtracted.
Yes.
That is 147. This is 30. Resultant is
Oh,
117.
okay. I didn't see that. Okay, sir. Understood.
Okay. Okay, guys.
Yes.
Okay.
Sir, on the left
So,
hand side,
yeah.
sir, on the left side, first we have taken 49 meters acting on 3 meters.
49 newtons, not meters.
Yes, sir, 49 newtons acting at 3 meters distance.
No. Don't tell yourself like this. We are
Okay.
taking the moment of forces to the left of x. How much moment each force is causing about point x. So now point x is the point when you are taking reaction, you have taken moments about a. Likewise, now you're taking moments about x. It's the same concept, Vijay. Only
Yes,
the
sir,
point
yes.
has changed.
All right. So now what we have done is 49 newtons acting from A to a distance of D 3 meters. So it is coming 147. And then now what
And
we
it is
have done,
and it is 147 clockwise. You can see in the diagram about x. This is going to
that
cause a clockwise movement. Yes or no?
if we are taking about X, A is acting clockwise. And then this
Upwards, so it is
30,
causing a clockwise movement, right?
yes, sir, yes, sir. Then 30 meters into distance 1 at point D,
And that is causing anti-clockwise movement.
clockwise. And now if we go on right side, it is
So the
15.
resultant is 117 clockwise to the left side.
Yes, sir.
And
Now
likewise,
distance,
likewise do for the forces on the right side by yourself and see where are you getting stuck, beta. Do and let me
sir,
know where are you getting stuck.
sir, there was a confusion in the down one, like 30 into 1. We are taking distance into 1. And then for the right side, D, we are taking 31 into 7. The total distance, 5 plus 2.
So how did you take the moments yesterday when you were talking, sharing about this reaction? How did you take the moments about X? How were you taking moments yesterday, beta?
We were taking moments like this only, but the distance was from the A because we were taking about A, na, sir.
So now the distance is from X. So what is the problem now?
Okay,
What is the
got it,
distance
sir.
of what is the distance of force RB 31 newtons from X? Tell me. Look at the line diagram. What is the distance?
1
What is the
meter.
lever?
Got it, sir. Got
It
it,
is
sir. Thank you so very much.
it is the same concept. No. It's nothing new. It's the same thing what you did yesterday. Yesterday you took moments about A. Now I am saying take moments about X. That's all. That's the only difference. The point of reference has changed. Concept of moment is not going to change.
Yes, sir.
Is that
Got
clear?
it. Thank Yes, sir.
Okay.
Yes, sir. Thank you so much.
Okay. Just for the sake of good order, I will now take, let's say this time I'll coincide with point C. Let's take moment of forces to the left of C. So obviously, point force at C is not going to cause any moment because lever will be 0. Guys, tell me, what will be the moment of forces to the left of C? Now we are taking moments about C, guys. Okay, X is gone. 49 newtons will cause clockwise moment, and it will be 49 into 5. Does everybody agree clockwise? Yes or no? This 49 Newton causes a 49 into 5 Newton meter clockwise moment about point C. This is point C, guys. Yes or no? Somebody who had a doubt who was discussing, is that correct now?
Yes, sir. Yes, sir. 49 into 5 and
So this will be 45, 4, 22, 45 Newton meter clockwise.
yes, sir. And
Another
90
force is 30 newtons anti-clockwise. So anti-clockwise will be 30 into 3, that is 90. The resultant will be clockwise of 155 Newton meter clockwise. Correct, bete? Yes or no? Right?
Yes, sir. Yes, sir.
And you have only one force to right of C because 50 newtons will have lever 0. The one acting at C will have lever 0. Now there is only one force to the right of it, that is 31 into 5, which is anti-clockwise. and this gives you 155 Newton meter anti-clockwise. Guys, don't you see that there is something which is happening is similar to what was happening for SF? In shearing force, the sum of the algebraic sum of the forces to each side, the numerical value yesterday came same. Only thing is, if on one side it was upwards, the other side it was downward, or vice versa. Today, similar thing is happening. The numerical value on both sides is coming same. Only thing is, if it is clockwise on one side, it is anti-clockwise on the other side, or vice versa, whatever it is. Now, this 117 again, if I come on the video, if I come on the video by unsharing the screen, and I hold this pen here, okay. Where is my X? Okay, now let us say where this white cap is there, let's say that is the X. Okay, where the cap ends, that is the X. Okay, and it is 117 clockwise here and 117. Okay, now the forces to the left of X are causing a bending moment about X 117, which are trying to bend this white portion upwards. The forces to the right side of X are also trying to bend with the same bending moment 117 Newton meter, and that black portion is tending to go upwards anti-clockwise. That means this 117 Newton meter is the force that is that is trying to bend the beam at X. Do you agree with me, guys? 117 Newton meter is the, can you see me in the camera? Because now I have removed the camera from my screen. Can you still see me?
Yes, sir.
Okay. So 117 Newton meter is the force which is trying to bend the beam at point X. 117 Newton meter is the force that is trying to bend the beam at X. Likewise, 155 Newton meter is the force which is trying to bend the beam at C. This 155 Newton meter at C and 117 Newton meter at X are the bending moment at these respective points. Likewise, at every point along the length of the beam, you can get the bending moment. And when this bending moment is plotted against the length of the beam, that diagram, like the SF diagram, will be called as BM diagram. Okay. But first and foremost, this anti-clockwise up and down, like up and down was replaced by plus minus by sign convention. This clockwise and anti-clockwise business is done away by introduction of a sign convention. Let me share the screen because you will not be able to see the screen then. Okay. Okay. Guys, have you understood what I have said? I am trying to say that 117 Newton meter is tending to bend the beam at X, and 155 Newton meter is tending to bend the beam at C. So 117 Newton meter is the value of the bending moment at X, and 155 Newton meter is the bending moment at point C. Agreed, guys? Understood better?
Yes.
Okay. Now, this anti-clockwise clockwise business also had to be put to rest. Okay. Like yesterday, a sign convention used which is reversed on the two sides, so that either it becomes plus 155 or minus 155. So whether you go do on the left side or right side, you'll get the same answer. What is the sign convention? When you go from left to right, for bending moment, the sign convention is clockwise will be taken as positive and anti-clockwise will be taken as negative. Needless to say, if you go from right to left, sign convention, you don't have to remember every time, you can just reverse it. Negative will be clockwise and this anti-clockwise will become positive. The fact that the two sign conventions have reverse of each other, opposite to each other, that means if you follow these sign conventions, then you'll get the same. Either you'll get plus on both the sides or you'll get the minus on both the sides. You are not going to get plus on one side and the minus on the other side. So this is how this particular thing is done. Now, one way of calculating the bending moment is you calculate at about 15 to 20 points along the length, plot and get the diagram. Perfect. But the problem is, whereas shearing force was still okay, bending moment, even if the forces don't change, you shift the point along the, see, I'm shifting the point along the beam. You shift the point along the beam, the levers about the points will keep changing. So bending moment at every point will have to be calculated again and again and again. Why? Because whether forces change or don't change, the lever in any case is changing. Therefore, the way I have shown you for the purpose of explanation as to what is bending moment, its calculation that way is not user friendly. It's not user friendly. Okay. Guys, how do we then get it? We can get it more conveniently from the shearing force diagram. That is why I had drawn the shearing force diagram. You see, where is point X on this shearing force diagram? Point X is somewhere here. Where? 1 meter from D. 1 meter from point D. Now you see, beta, how much is the area below the shearing force diagram up to point to the left of X? This is the area under the shearing force diagram to the left of X. How much does it, is this 1? It is plus. Why? Because it is above the X-axis. So it is plus. There are, 1 is this rectangle, 49 into 2. Other is this small rectangle, plus 19 into 1. And when you'll do it, you'll get 1 plus 117. Which we had to fight out with the different forces. Tomorrow, if you have 5, 6 forces, you'll keep fighting with these forces. And you'll keep struggling for the levers. Then somebody will say from D to C is 2 meters or 3 meters, somebody will miss out the lever. If you go to the shearing force diagram, the area under the shearing force diagram will directly give you the bending moment. Understood, guys? Let's look at C. We got a value of plus 155. How much is the area to the left of C? To the left of C is this and this area. It is plus 49 into 2 plus 19 into 3. And if you do it, it will come plus 155. If I have to calculate the bending moment at this point, suppose, instead of struggling with the forces on the beam, I will have the green shaded plus area and this green dotted one negative area. I'll find the resultant of the two and I will get the bending moment at point Y. Have you understood what I'm trying to say, beta? Yes or no? These two examples through X and C, are you convinced that whatever we were calculating can be more conveniently obtained from the SF table, SF diagram? Yes or no? Can be more conveniently obtained from SF diagram, guys? Do you agree? We got plus 117 at X, plus 155 at C, which is much more convenient than fighting with the levers. Yes or no, beta?
Yes, sir.
Yes.
Okay. So we will, this part that I have done, what I'm circling, was only for you to appreciate what is meant by bending moment. What is meant by bending moment? We will not be using this concept for the purpose of calculations. We'll be using the area under the shearing force diagram to get the BM. That will be much faster, much easier. And since you are going to use the shearing force diagram, that is why yesterday the full session was devoted to SF diagram. Why? Because if the diagram is wrong, it's going to give me wrong areas. It's going to give me wrong values. So therefore, To be able to use the shearing force diagram, it goes without saying that shearing force diagram in the first place has to be correct. And therefore, you need to be careful about the shearing force diagram. Guys, any questions on bending moment as a concept, if you want to ask? If you have no questions to ask, then I'll take this first question all over again from beginning. I'll write all the steps. I'll write all the steps and I'll do the complete question all over again, right up to the bending moment. And please, if you have any questions regarding even the shearing force, please interject then and there. Don't keep sitting with your problem, keep lying low on your problem, and then suddenly waking up at the last minute. Now, I'll do this question as I would do in the exam, and each step is important. And from after another one question, I'll ask you to start doing the questions. Lead me and I'll follow so that we iron out the issues at each step. Now, in this case, the first step is to make the beam diagram. I'll make the beam diagram and I'll say, okay, the first step is executed. I have explained in ample detail, but if you still have any doubts, let me know. This is my beam. Sorry, not plus 50 newtons and 2 meters from here, 30 newtons. This is 2 meters. This is 3 meters and this is 5 meters. The beam diagram is done. Any questions on the beam diagram, guys? This is what we mean by the beam diagram. Is that clear? Please keep confirming if the beam diagram is clear to everybody.
Yes, sir.
Okay. Next step is we'll calculate the reactions and I'll do that. Let this reaction be RA, this reaction be RB. We'll take moments about A as we did yesterday. So taking moments about A, clockwise, positive, anti-clockwise, negative. We have four forces, so I'll say RA into 0. 30 is causing clockwise about A, so plus 30 into 2. I'm talking to myself, look, and I'm going to the diagram every time, guys. About A, 50 newtons is causing clockwise, so plus 50 into 5. RB is causing anti-clockwise, minus RB into 10. And this gives is 0. Why? Because the beam is not rotating. The resultant has to be 0. This gives us RB is equal to 31 newtons. And this also implies RA will be equal to 80 minus 31 equal to 49 newtons. We put 31 newtons on the diagram here. We put 49 newtons on the diagram here. Any questions up to this step? The second step is done. Reactions calculated and loaded on the diagram. Any questions up to this point, guys?
Yes.
No, sir.
Next, we will look at the beam diagram critically and we'll identify the points which are essential or key points or important points for the SF table. Now, we said yesterday we had closed that issue. We said one is the end points. Second is all the points where you have the point forces. And third, wherever there is a change in the uniform forces, wherever there is a change in the uniform forces, these are the conditions to pick up the points. And based on these conditions, we have point A, B, and the 2 point forces. We can call them as C and D. Now, having identified the 4 points for which I need to make the shearing force table, now I make the SF table. or I can make the SF table here. SF table for 4 points. One, two, three, 4. Points has to start. We agreed we'll go from left to right for the purpose that upward forces then become positive, downward become negative. That is the only reason we agreed yesterday. So if we go from left to right, the points are A, D, C, and B. Here we'll have the shearing force. Here I'll put the units of the force. And then these cells, wherever there are point forces, at A, yes, there is a point force. At D, there is a point force. At C, there is a point force. At B, there is a point force. So we divide all these by because they all have the point forces. Now I'm telling myself and my eye goes to the diagram and then I keep filling up. To the left of A, the shearing force is 0. I carry forward 0. Change from left of A to right of A is plus 49, so it becomes plus 49. I carry forward plus 49. Is there a change from right of A to left of D? Pay attention. From right of A to the left of D, the change is 0. So the shearing force remains plus 49. I carry forward plus 49. From left of D to right of D, is there a change? Yes, minus 30. It becomes plus 90. I carry forward plus 19. From right of D to left of C on the beam, I don't see any change. Change is 0, so plus 19. I carry forward plus 19. Then at the beam, I see from left of C to right of C, minus 50 comes into picture, making it minus 31. I carry forward minus 31. From right of C to left of B, I don't see any change, so minus 31. I carry forward minus 31. From left of B to right of B, plus 31 comes into picture, becomes 0. Let me draw the separation line in a different color so that people don't have any confusion. And I doubt anybody will have any doubts. But if you still have any doubts, let me know. These are the cells divided, right? Tell me, guys, is the shearing force table making clear to everybody now?
सर थोड़ी
Is
सी
that clear?
कंफ्यूजन होगी सर, थोड़ी कंफ्यूजन होगी। जैसे उसमें अभी 30 × 2 लेंथ के साथ करते थे सर, वो फोर्स निकाल लेते हैं।
कल ये किया था 13 to 2 किया था कल।
नहीं सर, ऐसे ही किया था, ऐसे ही किया था। जैसे अभी थोड़ी देर पहले वो क्वेश्चन कर रहे थे तो उसमें
तो वो क्या कर रहे? What were we doing there? What were we doing then? What were we calculating?
पॉइंट पे फोर्स निकालते हैं।
What were we calculating? Name the thing that we were calculating.
फोर्सेस सर।
We were calculating forces. Today we started the lecture by calculating forces. Is that what you're trying to tell me?
Moment.
Moment sir, moment निकालते लीवर
And
के
what
साथ।
are we now making?
ओके सर, एसएफ शेयरिंग फोर्स का वो निकाल रहे हैं।
So are the two same?
नहीं सर, अंडरस्टूड कंफ्यूजन।
Okay. Now based on this table, I'll make the shearing force diagram. I make the diagram like this. I have a requirement down below also. So I have this beam, I have this point A, I take a suitable scale, 2 meters from here, whatever scale I take, I mark D. Using the same scale at 3 meters, I mark C. Using the same scale at 5 meters, I mark B. So this is 2, this is 3, and this is 5. On the x-axis is shearing force. I put the Newton, sorry, and you will now calibrate the axis so that you don't have to put the scale. So a suitable scale, plus 10, 20, 30, 40, 50. So plus 10, plus 20, plus 30, plus 40, plus 50. Minus 10, 20, 30, 40. Now, I have a look at the shearing force table, and using those values, I draw the shearing force diagram. At A, it goes from C, so it will be, now what I'm doing is not for, or let me do with the laser. When it comes to plotting, you will basically first plot this one. From here, you'll go to this value. From here, you'll go to this value. Then you'll come to this value, then go to this value, then come here, then go there and come here. This we had addressed yesterday also, guys. I don't think there should be any doubt about that. So from A, we go to plus 49 somewhere here, A to plus 49. Then from up to D, it remains plus 49. So up to D, it remains plus 49. At D, it reduces to plus 19. Then it remains plus 19 up to C, wherever it is, to the scale, of course, plus 19. So plus 19 to C. Then it becomes minus 31. So somewhere here it comes down. Remains minus 31 and becomes 0. This is my shearing force diagram for the question. Guys, any question on the drawing of the shearing force diagram, or it's good? Good, beta? Is that clear, beta? Up to
Yes,
shearing
sir.
force
Yes,
diagram
yes,
is
sir.
good, guys. So it's a repeat
Yes,
of
sir.
what we did yesterday, okay? But now through the proper procedure. Now, my job of the beam diagram is over. Once the shearing force diagram is given the shape, to get the values and to give the shape to the shearing force diagram, I was referring to the beam diagram. Now the job of the beam diagram is over. Now attention shifts to the shearing force diagram. Pay attention to what I'm saying. Now you will identify critical points for the BM table. You will identify critical points for the BM table. Okay. What is the criteria for that, beta? It is a very simple criteria. Number one, all the points at which SF was calculated by default qualify for BM. Whichever points you had calculated the SF, by default, they get picked up for BM. In addition to that, in addition to those, if the shearing force diagram is crossing the x-axis at any additional point, I repeat, if the shearing force diagram is crossing the x-axis at any additional point, then that point also needs to be picked up. Have you understood the condition for picking up the points for BM? All points which were there in the SF table, plus any additional point where the shearing force diagram may have crossed the x-axis. So with these two conditions, look at the shearing force diagram and you tell me how many points need to be taken for BM. How many points need to be taken for BM? Tell me, guys.
So same for A, B and B.
Same for, okay, same for. Why? Because it is crossing x-axis, but it is crossing at one of those points only. It is crossing at C, so C is already there, right? Yes or no, beta?
Yes, sir.
So has everybody understood the criteria for picking up the points? All points at which SF was calculated, plus any additional point where x-axis may have crossed the x-axis. Sorry, my mistake. Any additional point where SF may have crossed the x-axis. Is that clear, beta? Guys, are the conditions clear?
Yes, sir.
Okay. So in this case now, I will make the BM table. BM table, and I will write here by areas under SF diagram. I'm telling by how I'm calculating the BM. And as you have told me, 4 points are good enough, so I'll make it with 4 points. 1, 2, 3, and 4. Order will be same, A, D, C, B. Here I'll get BM. Unit of BM will be what? Force into unit of length. Force is Newton in this question. Length is meter, so BM will be Newton meter. Now, just one time you do it, if you don't understand, just tear off a page, keep it in your hand, and cover the SF diagram in such a way, put it on the SF diagram and see how much area of the SF diagram is to the left of A. How much area of the SF diagram is to the left of A? Tell me. How much area of the SF diagram is to the left of A, guys?
None, sir.
0, sir.
0.
Everybody agrees. So BM at A is 0. Does everybody agree? Yes or no? I said, if you have any problem, cut a piece of paper on the screen itself. You put your paper in such a way that your paper is aligned with the x-axis, and now it will cover the right side of the diagram. And then to the left of the paper, is there any area under the curve? No. So the BM at A is 0. Understood, guys?
Yes, sir.
Then we'll carry this 0 forward. Now slide your paper to point D and see what is the change. Now I'm talking about the change. What is the change of area with sign taking place from A to D? What do I multiply with what?
Plus 49 into 2, 98.
Plus 49. No, write like this only, no problem. Plus 49 into 2 is the change taking place from A to D. Does everybody agree? Guys, we are talking of this area. This is the change. You don't have to shade it. I'm shading it only for explaining. And this area will be 49 into 2. Yes or no? Yes. So the bending moment at D would be plus 98. Any questions up to bending moment at D, guys? Please let me know if there's any concern.
No, sir.
Carry forward this plus 98, bete. Now slide your paper to C. Now pay attention. What is the change from D to C? What to multiply with what with sign?
Plus 19
Plus
into
19
3.
into 3.
Plus 19 into 3. Pick up the calculator and give me the resultant. 57, 57, 155?
155.
Plus 155, yes or no? That is the BM at C. Carry forward this 155 plus 1, sign plus 150. So, right, guys, please don't tell me tomorrow that I didn't put a sign, it was plus. Please put a plus sign. Okay. Plus 155. Take your paper to B. What is the change taking place from C to B? It is minus 31 into 5, if I'm not mistaken. And this becomes 0. Yes or no, beta? These are the bending moment values from A to B at the 4 points. Understood? First, let me address if you have any doubts about the table, BM table. Up to SF, we had done yesterday. Okay. Then, now we make the BM diagram, and that ends the question. Then let's make the BM diagram. I look at the values, they are all plus, 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 so I don't have to have anything below the x-axis. This is my beam A, 2 meters from A is D, 3 meters from A is C, and 5 meters from here is B. First, I will put these values. Let me graduate the scale. I have up to plus 150. So here is BM, right, like this. Units will be Newton meter. I can say this is plus 50, plus 100, plus 150. And you can mark plus 200 also. Now let me mark these values. At 1A, it is 0. At D, it is plus 98. At C, it is plus 155. At B, it is 0. Now the question is, how do I join them? My question to you is, and I'll answer myself only, how have we got the BM? We have got the BM by integrating areas under the shearing force diagram. Look at the shearing force diagram, guys, and what I'm drawing is you don't have to draw. Is the shearing force area from A to D changing at a uniform rate, yes or no? If I divide it into equal parts, say half a meter each, is every half a meter the area is changing equally, yes or no? My question is, from A to D, is the area changing at a uniform rate?
Yes, sir.
Yes or no?
Yes, sir.
Yes.
Now I'm asking about area. So your focus has to be on area, not on the beam diagram, your SF diagram. So if the area is changing at a uniform rate from 0 to plus 98, that means the graph will be a straight slanting line. It will be a straight slanting line. So I'll pick up my scale, put on these 2 points and join them with a exact straight line. There's absolutely no doubt about it. Then I have to join D and C values. I look at the diagram again. Guys, is the change from D to C at a uniform rate, yes or no? Area
Yes.
change from D to C, is it uniform rate, yes or no?
Yes, sir. Uniform.
Yes.
Guys, this horizontal graph represents uniform rate. Horizontal graph means uniform rate, right? So likewise, we'll join these with a straight line. Same question I ask myself, how is the change from C to B? The answer is uniform. So I put a scale again and join them with a straight line. And this red line, the red diagram that we have drawn is the BM diagram for the question, and the full SF question gets SFBM question. The simple one gets completed. Now, don't run ahead of the class. Don't say if it was not a straight line, if it was not a horizontal line, what will we do? Don't worry about all that. Have you understood this basic concept as to why they were joined by straight lines? And where were we looking at? We were looking at the SF diagram. Is this SFBM question clear to everybody? If you have any doubts about SFBM, this SFBM question, please let me know. Guys, if you don't have any doubts, I'll go to the next question. Please let me know if there is any doubt.
सर एग्जाम में ग्राफ पेपर मिलता है फिर शीट पे बनाना पड़ता है?
बेटा ये तुम्हें पता होना चाहिए, मैंने तो आज से 40 साल पहले एग्जाम दिए थे.
सर हम भी पहली बार ही थे.
Graph.
क्यों? Why you didn't write certificate? You are a BSc guy, is it?
Sir, Delhi MMD में नहीं देते graph.
That's what I'm saying. I didn't want to. Every MMD has its own concept, and tomorrow, first and foremost, when boys ask me, should we practice on graph? Guys, if you have not practiced on graph, you can always use the graph. But if you have practiced on graph and graph is not available, you will be stranded. Many of you will lose your bearings. So please be prepared to work without graph. And then if you get graph and you want to use it, that's your choice, right? And another risk graph has is any attachment, there is always a risk of being lost. Yes or no? And then you'll come and tell me I had plotted correctly. Maybe my graph has been put to somebody else's answer sheet. So it's your take. Every MMD has its own way. Sometimes they give, sometimes they don't give. Anyway, more than the graph, तो ये question clear हो गया. पहले ये बता, जो मेरा question था उसका जवाब नहीं दिया तूने, question और MMD का लेके आ गया. Is the question clear to you? That is more important than the graph at this point in time. Guys, I'm switching to the next question. If you have any doubts, let me know quickly. Okay, I'll take one more question from the yesterday's one, complete that like this, and then I'll go to straight MMD questions. A 10-meter long beam of AB of uniform cross section. I'll cut short little bit about calculation of reactions we had done yesterday. That will not be doing now today. AB supported on the knife has supports at the ends, 50 newtons at the rate of 5 Newton per meter. Okay. We had calculated the reactions yesterday and they both came 25 newtons. Do you remember, guys? Yes or no? Such simple case, you don't have to calculate also. By looking at it, you know it is symmetrical. So 25 newtons. I doubt anybody has any questions to ask on the up to reactions, guys. Is that clear? This we had done yesterday, beta. Correct? Am I right?
Yes,
sir.
Okay, this was the second question we took yesterday, guys. Okay. Now, we will pick up the key points. In this, we said minimum 2 points A and B. So we'll now make the SF table using only 2 points A and B. SF in newtons. At A, you have a point force. At B, you have a point force. Therefore, both need to be divided. Do you agree with me? Do you agree both need to be divided, guys?
Yes, sir. You need to divide.
Yeah, so you should not have any doubts as to we were doing everywhere, why we have not done here, why we did there. So it is both our point forces need to be done. Okay. What will be the shearing force to the left of A? It's going to be 0. My eye is on the beam diagram. You see, I'm looking at the beam diagram and completing it. I carry forward 0. Change from left of A to right of A, plus 25 comes into picture, making it plus 25. I carry forward this plus 25 here, and from A to B, the change is minus 50. The full weight of the beam left of a B becomes minus 25, minus 25, plus 25, 0. Anybody has any questions on the SF table, let me know. Please interject wherever you have the issues.
sir.
Yeah.
From this SF table now, you can see that at B it will be minus 25. So in that case, this clearly shows that this will be crossing this SF
So
line.
let it cross. No, let's make the SF diagram. Why are we jumping to BM? If it is crossing, let it cross. When we come to BM, we'll discuss that. Na, bete?
Okay.
Correct. That has nothing to do for the SF diagram. SF diagram will take its own course. Yes or no?
Yes.
Right. If I'm doing this question, I'm doing with certain purpose only. Na, bete? There is something I want to add to your stuff, right? Okay, don't worry. So we make the SF diagram now. And anybody who does not agree up to SF diagram, please, last opportunity for you to speak out. A, B, 25 meters in 10 meters in length, plus 25 minus 25. Shearing force in newtons, both up and down. I can change to some other color so that with the axis it does not coincide. It goes to plus 25. And from here it comes to minus 25 here, beta. Now my eye goes where, now to decide whether I join with straight line or how do I join, I take my eyes to the beam diagram. And when I look at the beam diagram, I see that the change from A to B is at a uniform rate because of the uniform cross section of the beam, uniform weight of the beam. And therefore, these 2 points will have to be joined by a straight line. This is minus 25 and then it becomes 0. This is the SF diagram of this particular question. Do you agree, guys? Yes or no?
Yes, sir.
Guys, any questions up to the shearing force diagram before we go to BM table? Now, somebody who was speaking now, better come in. Now I think your point is valid. Okay, come in now.
Yes, sir.
Now, for BM, you have to take both A and B because they were used for SF. And has the SF diagram crossed the x-axis at any other point? Yes, it has crossed here. Now you have to see where does it cross. In this case, it will cross at the mid length. Why? Because it is 25 value this side, it is 25 this side. Both values on the side ends are same. So it will cross at the mid length, guys. You see, this will not be so. We'll deal with the situation when we reach there. You see, suppose it was plus 75 here, and suppose it was minus 25 here. Then if you join them, then it will cross here, not at the mid length. Do you agree? Why is it crossing at the mid length? Because it is plus 25 on one side and it is minus 25 on one other side. Both values are same. Therefore, the 0 will come midway. Yes or no, beta? Correct? Am I clear, beta? Why it is crossing mid length?
Yes, sir.
Okay, so every case it will not be so. When it does not, it is not so, we'll see that. So when it crosses mid length, that means I'll have to take this point also for BM table. So I can call it as C. This is 10 meters, this is 10 meters because it is crossed at mid length. Now we make the BM table, beta. How? By areas under SF diagram.
So 5
So
or
it
5.
is 5 होगा ना, sir?
My mistake. So my mistake.
5,
Sorry.
yes, sir.
Sorry, my mistake. Sorry. Thanks. 5. Okay. I thought 20 meters. Okay. Thanks. So BM table by areas under the SF diagram. We have to make it for minimum 3 points. And those 3 points in the order are A, C, B. My BM will be in Newton meters. Guys, what will be the BM at 0 based on our discussion in the last lecture, previous question? BM at 0, BM at A? What will be the value? 0. Okay. I carry forward 0. What is the change from A to C? Just tell me what to multiply with what. Don't tell me the value. And with sign. What is the change taking place in the area from A to C?
25 into 5. 25 to 0.
10 by 2 into 25 into 5.
Half 25 into 5.
Very good. Area of the
62.5.
positive triangle plus half into base into height. Yes or no?
Yes, sir.
So plus 62.5. Yes or no, beta?
Yes, sir.
$62.5 because it is exactly the same triangle and becomes 0. I don't have to calculate again there. And this becomes the BM table. First, everybody has to confirm to me that they are okay up to BM table. Any questions up to BM table before we go to BM diagram?
Sir, once again, you can explain this RA-RB is 25.
Yeah. So
Calculate RA-RB 25. Uniformly weight is there, 5 Newton per meter.
Why yesterday we calculated? No, you're not in the class yesterday.
No, I was in the class, but this uniform.
So the second question we did not calculate by moments. Second question you did not do.
No, I attended that.
So yesterday we calculated it.
Okay, copied, sir. Yesterday. Okay.
Yesterday we calculated it, beta. It will come
Understood,
25, I
understood,
know,
understood.
but I don't want to confuse you by making statements from here. That's why I calculated yesterday, so that people don't, because I know some of you will always have that problem if I want to try to cut short, because it's symmetrical about the center line and those. So anyway, leave that. Guys, is the BM table okay with everybody? Now we come to BM diagram. It's all plus, no minus, so no need to have anything below the x-axis. So I can have the drawing like this. I have A, I have C, and I have B. My maximum value is plus 62.5. This is BM in Newton meter. Now, I'll put the values first. Let me put the values, and then we'll see how to join them. That we'll discuss later. At A, it is 0. At C, it is plus 62.5. At B, it is 0. Now the question is, how do I join value at A to value at C, and then from C to B? Now, guys, I'll use this sheet and then delete, but then that will also get deleted. So let me just do one thing. Just escape once by saving. And then I now go again in the slideshow. Okay. Okay. Now, guys, you see, ours is this triangle like this. Our SF diagram is a triangle like this. Now you see, from A to C, if you divide this on the base equal things, is the area changing at a uniform rate? First tell me yes or no. Is
Yes,
the
sir.
area from A to C changing at a uniform rate?
Yes, sir.
It is changing at a uniform rate?
No, sir.
Is this
No, sir.
area 1 and area 2 equal? If these are X and X?
No, sir.
No, sir. Not at a uniform rate.
So why you're saying they're changing at uniform rate, beta? What made you say so? I have divided them here, and that is also not giving you a hint, huh? So from A to C, the areas are not changing at uniform rate, okay? That means you are basically integrating areas under a slanting straight line, not a horizontal line. Previous question, the SF diagram was horizontal. Here it is slanting line. When you are integrating under a horizontal line, as the previous question, your result will be slanting straight line, as we saw. If you are integrating under slanting, this is slanting straight line, this will result into a curve. It will not give you a straight line. So the graph of this will be a curve. Now we have taken bare minimum points. How do we get the right curve? There are two things you have to keep in mind, and these are the tips I'm giving you. They are not standard tips, basically. The area can be required to be integrated like this, or the area could be required to be integrated like this. Integrated like this means you're adding from this side and going this side, or starting from vertex and going towards the base. In our discussion, we will call it, this one will call as base to vertex. This one, we go like this, we call it as vertex to base. Okay. Guys, when we are going from base to vertex, the first diagram, you see initially the area change is maximum, and then it is slowly reducing, yes or no, and becoming 0 at the vertex, yes or no, beta? First, the rate is more, then the rate is slowly reducing, yes or no? Correct? Yes or no, beta? This area 1, 2, 3, 4, 5, 6. They are all reducing, no, as we are going towards the vertex. Yes or no, beta?
Yes, sir.
Yes, sir.
So the rate is gradually decreasing. Rate of change is reducing. Yes or no? Correct?
Yes, sir.
Yes.
But if I go from vertex to base, what is happening to the rate? Is it increasing or decreasing?
Increasing.
Increasing.
Now 1, 2, 3, 4, 5, 6, 7. So it is increasing. So when you go from base to vertex, the graph will be like this. How will be the graph? First, the rate is more. More rate means steep line. Then the rate is decreasing. That means now it is becoming nearly horizontal. This will be the type of graph if you are integrating from base to vertex. Am I clear, beta?
Yes, sir.
Initially, the rate is more than the rate, because when the graph gets horizontal, the rate becomes 0. So rate is reducing as we are going towards the vertex. If you are integrating like this from vertex to base, first the rate will be less. Rate will be less, and then the rate will be rising. You see the two graphs are different. This is the graph from vertex to base, and upper one is the graph from base to vertex. This is base to vertex situation. This is vertex to base situation. Have you understood, beta? Yes or no? Have you understood? Will you be able to remember these two graphs, beta? How the graph is to be shaped? Because then you'll be able to shape your graph easily with limited values. Will you be able to remember this?
Yes, sir.
Okay. Another thing, another property of a triangle which you can remember and make use of if you want, that if this area of the triangle is A, and then you take on the base a midpoint, on the base you take a midpoint, that's you can calculate with the, check with the formula also, it will automatically come, will not go into that domain. If I take a midpoint, then this divides this A into two areas, A1 and A2. In a triangle, when you do this A1, the area of the small triangle will be always 75% of the total triangle area. Sorry, 25, my mistake, 25% of the total area. And area 2, that is of the trapezium, will be 75% of the total area. You can also use this property for quickly putting a point in between and giving you a better shape, if you can remember this. And this is the property of a triangle, not any other shape I'm saying. For a triangle, when you take a midpoint of the base, it will divide the area of the triangle into two parts. The one which is a triangle will be only 25%, 1/4 of the total area. The trapezium area will be 3/4 of the total area. That is the property of a triangle. Is that clear, beta? I'll be using these properties which I have explained on this page to give a shape to my BM on the previous case. I will be asking you questions from A to C. Am I integrating the triangle from base to vertex or vertex to base? A to C, is it from base to vertex or vertex to base?
Base to vertex.
Vertex.
Base to vertex. So initially it will be steep, and then something like this. It will be basically like this. Yes or no, beta? Correct? Yes or no?
Yes, sir.
Okay. Now you see, somebody will say, sir, how could I use that property? You see, if I imagine a point midway, then this is from here to here is the trapezium area. It will be 75%. What will be 75% of 62, beta? Can you multiply 62.5 by 0.75? Or you can see here, you don't have to do that. What you can do is divide this into 4 parts. This scale. At the mid length, you see, without marking, I am nearly getting the same value. You see. Why? Because without marking also, because I followed that rule that the initial part will be steep and then it will get horizontal near the vertex. Guys, the other triangle from C to B, is it from vertex to base or base to vertex?
Vertex to base.
But vertex to base.
It will be a mirror image of it. That means towards B, it will be steep, and towards C, it will be horizontal. It will be a mirror image of this thing. So it will be absolute mirror image, If you just flip it vertically, this part, this will be a curve like this. It will be initially steep and then get horizontal here. And this will be the BM diagram for this question, made with only 3 points, A, C, and B. If you keep in mind how the areas under the triangle will be integrated, how the areas under the triangle will be integrated. From vertex to base, it will be first horizontal, near horizontal like GZ curve, and then steep. From base to vertex, it will be first steep and then horizontal. Have you understood better? Guys, if anybody has not understood this concept of triangle, let me know. That was the reason why I took this. One, it gave us additional point for the BM table. And secondly, we got the areas under a slanting line and not along under a horizontal line. So I wanted to address those 2 points through this example before we embark on MMT questions.
सर एक बार लास्ट पेज वापस समझाइए.
इस पेज पे समझ में आ गया बेटा जो किया है? इस पेज पे कोई डाउट्स?
इधर कोई डाउट नहीं सर.
इधर कोई डाउट नहीं है तो मैं दिखा देता हूँ. बोलो क्या डाउट है बेटा. देखो नेक्स्ट पेज देख लो, बताओ मुझे. See, when they are using lesser points, then you will have to be smart to give shape. You cannot just join them whichever way you want.
Sir, so one doubt.
Yeah.
Sir, this for clarification. Wherever this SF line cuts the base, does BM will be always max? This stands for every situation.
Beta, there will be always a maxima or a minima. It will be a point of contraflexure where the curvature will change. If it was increasing, from there it will start decreasing, or if it was decreasing, it will start increasing. So wherever it will cut the x-axis, there will be a point of inflection. That means there will be a maxima or a minima, but whether it will be in absolute terms maximum there or not. In this case, since there's only 1 point, yes, it is maximum. But in some curves, there can be multiple maximas and minimas also, no?
Okay.
Okay. But what you are saying is correct. Whenever the shearing force diagram will cut the x-axis, there will be a change happening. That means if it was increasing, now from there it will start decreasing, or if it was decreasing, it will start increasing. There will be a change. That's correct. What you said.
Okay.
There'll be these are the points of contraflexion from where the curvature will start changing. Yes, that's right. Okay. Guys, don't worry, don't get panicky. Just keep in mind what I have told you. We'll be doing at least a couple of questions, and they'll be from MMD exams. And in those, we'll address all these things as they come. But what is important is for you to participate in those questions. You cannot be just noting down from the slide, beta. Okay.
Sir, in the last slide, this
yeah.
From C to B, I cannot relate that vertex.
Okay. No, okay. If you have to draw it from B to C, how will you draw? Then you will be able to relate.
From B to C, it will be same like A to C.
So then that's exactly what I said. It's a mirror image. Now you can correlate. First, it will be, if you're drawing from C, first it will be near horizontal less, and then it will become steep. Yes or no?
Yes, sir.
Or if you're drawing from B, first it will be steep, and then it will become horizontal. Yes or no?
Yes, sir.
Because that depends whether you're drawing from C to B or you're coming from B to C, right?
Yes.
Have you understood what I said, beta?
Yes, sir.
Okay. Guys, this is a MMD question. Now, before I go to MMD question, I want to address one more thing. Until now, we have used the force of Newton or kilonewton, which is actually the SI unit of force. Okay. In ship stability, like thrust we express in tons, pressure we express in tons per meter because we keep G aside for the sake of convenience. Okay. So in our questions also, many a times the weights are given in tons or kg. Now, these can be converted into Newton and kilonewton by multiplying by G. When you multiply kg, weight in kg, by acceleration due to gravity, it will convert to Newton. When you multiply weight in tons with G, it will convert to kilonewton. Okay. Should we convert every time? Not necessary. Okay. You look at the values given. If those values are given as whole numbers in kg or tons, you can continue working in kg and tons and express the shearing force in tons and bending moment in ton meter. Okay. If the values in tons and kilograms are given in decimal places, see if by multiplying by acceleration due to gravity 9.81, is it rounding off to something better? If it is rounding off to a better value, then you can convert them into Newton or kilonewton as the case may be, and then solve the question in Newton and kilonewton. Guys, am I clear in what I said, or anybody has a doubt? If tons and kilograms suit you because they are given in whole numbers, you can directly use them. No need to convert, because if you multiply by G, they'll convert into some fancy fractions. Okay, decimal places and all that. So if you're comfortable without conversion, you can use without conversion. If you think conversion to Newton, kilonewton simplifies, please do convert them. Am I clear, beta?
Yes,
Am I clear, guys? If the forces are not given in Newton, kilonewton, they are given in tons or kg, then you can take a call whether to use in kg and tons or to convert them to Newton or kilonewton. Right, beta? Yes or no? Understood, guys?
yes, sir.
Okay, so don't get confused.
Main idea
That
is
some
for whole figure, no, sir? Main idea is
Sorry?
for whole figure.
Sorry?
Main idea is for whole figure. We get whole
To
figure
get
by
a
doing.
comfortable figure to comfortable numbers to work with, yeah.
Okay.
Right? So when you multiply kg value with G, you'll get newtons. When you multiply ton with G, you'll get kilonewtons. So remember that. Don't get confused again. Okay. Here is MMD 2022. A uniform beam 16-meter long, weighing 112 kg, is supported at a point 2 meters from end A and at a point 4 meters from end B. It carries a point load of 13 kgs at its mid-length. Draw the SFBM diagrams of the beam and state their values at the point 2.55 meters from end B. So leave the last part completely. This part you can leave out for the time being. Once we get both the diagrams, we'll come to this later. Okay, leave this part right now. Please, now I will ask you to do, please do it. Lead me, make it. If there is a mistake, you will be able to correct. First thing is, please make appropriate beam diagram, guys. Please make the beam diagram. I will not speak when I'm making. I'll make it. You will compare. If you're correct, fantastic. One step done. Nothing to worry about the first step then. If there are mistakes, and if you can understand your mistakes by yourself, please correct. If you need discussion, indulge with me, involve with, me into the discussion, and I'll be happy to answer. Please draw the diagram. Read the question, draw the diagram, guys. Don't sit. If you keep sitting, you'll not understand. I can bet on it. And if you do this question well, you'll be able to attempt most of the beam questions. I can tell you this also. And obviously we'll keep it in kgs because it's 112 kg. So we'll keep in kg, okay? So guys, I have made the diagram. If your diagram is similar or same, rather not similar, it has to be same, then good. If not, please let me know where is the difference.
Same.
Very good. Anybody who messed up the diagram, you want to voluntarily own it, and maybe then that will register better in your heads. Okay. Now guys, we have to get the reaction. So first let's name these 2 points where the supports are. Let me call them as X and Y. So let's all of us name them the same way. Now, can you please calculate Rx and Ry, guys? Please calculate Rx and Ry. I don't want to speak anything. Because as I said, if you make mistakes, that's the only way you'll learn. And if you don't make mistakes, then fantastic here. So first step well achieved, diagram made. Now the question is, we want to get Rx and Ry. Please write the full statements, don't cut short.
Sir, here why we are not calculating from A, sir? We are calculating from X only, right?
I don't know.
RA,
I have made some explicit statements. Where will the reaction act? Will the reaction act at A?
no, sir. Because support is there, that's why we are calculating from X.
I don't know where you are calculating from. I'm just saying, will the reaction act at A? Yes or no?
No, sir.
Why? Tell me why also. Because yesterday I spent almost a session on this damn thing only here. I don't know whether some of you, to me, it appears some of you don't attend the classes and then suddenly you come up with issues. What gives rise to reaction? Can you tell me better? What gives rise to reaction?
Weight, sir. That weight will give the reaction.
And where is the weight acting? Where is the weight acting?
Weight acting at X because they're getting
Only
support.
X? Is it only acting at X?
No, sir. The uniform beam is 16 meter long. So
My question is not about how is the beam. My question is where is the weight acting? That is my question.
weight acting at midpoint for the uniform beam.
Weight is supported at the midpoint. That's what you're saying, is it?
Acting
so then the reaction should the reaction not be at the midpoint then? कल बेटा आपने शुरू का लेक्चर सुना था when I was explaining the third law of Newton's third law? I mentioned something. I mentioned. Were you there in the class that time?
Yes, sir. Yes, sir.
So what was it I trying to explain then? I'm trying to take you back in time so that you can correlate.
Yes, sir. For uniform beam, the full weight will.
I'm not talking of uniform beam. I'm talking of any beam.
Mhm.
Where is the weight of the beam acting? What is taking the weight of the beam? What has taken the weight of the beam?
Support, sir, support.
Where are the supports?
Supports are at X and Y. At
So
the
then,
points of.
if the weight acts at X and Y, the reaction will act at X and Y only, no?
Okay, sir. Yes, sir. Understood, sir, because we are getting
Okay, continue.
support.
Get the values. Get the values, please.
Ri will be 75 and Rx will be 37.
I'll take from you. Okay, 75 something is saying. Take, okay. I'm doing my way. If you have taken about Y, it's okay. Taking moments about X, clockwise positive. Please write everything. Anti-clockwise negative. Right pull. 1, 2, 3, 4 forces. So Rx into 0 plus 13 into 6 plus 112 into 6 minus Ry into 10. This is equal to 0. This implies Ry is equal to 78.
75.
Yeah, 78. Okay, 78 plus
60.
112, 12, 7, 672.
672.
Okay, divide by 10. 75, is it?
Yes,
Ry
sir.
is 75.
75. Yes, sir.
75 kg. Rx will be equal to 112 plus 13 minus 75, that is 50 kg. So Rx is 50 kg. Guys,
Yes.
is everybody good with the reactions? If you're okay with that, then the second step is done.
Yes, sir.
We have to address one step at a time. Only
So that
one
is
step at a
13 into
time.
6 plus 112.
Sorry?
So here Rx into 0 plus 13 into 6 plus 112, no?
Plus 112.
Sorry, let me see what have I done. What have I done?
Into
Let
कर
me
दिया,
see.
into 112 into 6.
Okay, okay, plus है बेटा, that is plus.
Yeah,
plus.
that Rx, Ry is coming 75. वो तो correct.
Okay, that's plus only. That's a mistake, writing mistake. Okay. Guys, 2 steps done with everybody. Drawing the beam diagram, getting the reactions. Anybody still struggling, let me know. Hamesha do with stepwise and see where are you getting stuck so that you know which area has to be emphasized upon. Don't look at the complete question in one glance because then it will look unnecessarily overwhelming. Okay. Now, please identify the points for the SF table. First, tell me how many so that we can write if any other point is to be named, we'll name. Is there any other point to be named?
Excuse me, sir.
Yes.
So the point where 13 kg is acting.
Yeah, so
Yes,
I'm asking you, is there any point to be named?
Yeah, 13 kg center one we can.
Okay, so
13 kg
let's call it as C.
Yes.
Any
Yes,
other
sir.
any other point to be named for SF table, beta?
I think it's okay, sir.
Okay, then make the SF table for 5 points then, guys. Please make the SF table for 5 points. Again, I'll not speak anything. I'll only address the doubts when you have. This time the SF units will be kg. That's all I want to warn you. SF units will be kg, beta.
Yes, sir.
Excuse me, sir.
Yes.
Sir, when we are calculating the moments
Yeah, so
about
what
X,
happened?
so will we not consider this distance from A to X, point A to point X? I got a little confused there.
Why you're confused if the full beam is taken as 1 for purpose of moments? Where is the confusion? Is that length not included in the full beam?
Yes, we have included, sir.
So then if you're taking for the purpose of moments full beam as one body, so
Sir.
why this part has to be separated for moments? If you divide into three parts, one from A to X, other from X to Y and Y to B, then each part will have a different center from X and answer will be same, but you will be unnecessarily making your calculation much lengthier, right? Because if you take AX separately, then the remaining will be A to B, correct?
Yes, sir.
So then you'll have to use two components. So why you want to use two components when the entire body can be taken as one for the purpose of moments?
Okay,
Why
sir.
you want to
Then
fragment it?
that is where I got confused, sir. When we will use this, like when we will separate the bodies.
If you want to separate, then separate from A to X and then X to B will be other part. Then calculate with the two separate parts. You'll get the same result.
Okay, but then it will be separated in three parts, no, sir? A to X, X to Y, and Y to
That's
B.
up to you. You can separate into 10 parts, 1 meter each, beta. That's your choice.
Okay, sir. Okay.
You can moments. If I don't want to take complete moment of something, if I want to divide into 20 parts, I'm at liberty to do so, na beta.
Yes, sir. Yes, sir.
But is that a user friendly way of doing?
No, no, sir.
So then why should you get indulge into it? I'm not saying that by moments it will go wrong, but if you're taking AX, then you can't take AX again. Yes. And then AX moment about X will be anti-clockwise, the remaining will be clockwise. You'll have to be mindful of all those things, right?
Exactly, sir.
But if I'm saying this full beam of uniform cross section is one body and its entire 112 can be assumed to be acting through its center, the matter is put to rest, no?
Yes, sir.
For example, if in this beam, suppose I want to take moment about the midpoint, about
Yes,
C of the beam, what will be the moment as per you about the midpoint? Now you'll say, sir, I'll take moment of this separately. Then what will happen? This will be this way, this will be this way, they'll be equal, it will be zero. But why can't you take straight lever is zero? Yes or no?
Yes, sir.
Have you got my answer now?
Sir, I'm
If you
still
were to
thinking of.
take the moment of uniform beam about its center as per your concept, as per you, then you will like to divide the beam into A to C one part and C to B as another part. Yes or no, beta?
Yes, sir.
Then geometric center of this part will be here. This will cause anti-clockwise moment. This will cause clockwise moment. Both will be equal. The resultant will be zero. Correct? Yes or no?
Yes, sir. Yes, sir.
But if you take this full body beam as one and its weight acting through C, then the lever is zero. The moment is directly zero. No, why should I go in indirect steps?
Okay, sir. Got it. Got it. Thank you, sir.
There's no need to go roundabout. No, you can do that way. I'm not see if I cannot make a technically wrong statement by saying no, it is wrong. You can do things in those ways, but they are not the user. That is not a user-friendly approach, bete. Okay. Okay. Please make the SF table. Let me make, and then I'll ask you. I'll not speak anything. If anybody wants to ask, or if I make a mistake, you can correct me. No issues. Okay. Sorry, my mistake. I made a table wrong again. Okay.
दो
कोई बात
part
नहीं, I'll
plus.
take it next time. Yeah, I forgot. In the discussion of moment, did not divide into two.
Yes.
Yeah. Okay. This is the SF table. Let me make it here. 7 kg at X and Y and C. X, C. Okay. Guys, it's 0, minus 14, plus 36, minus 6, minus 19, minus 47, plus 28, and 0. Correct?
Yes, sir.
If anybody has not got the values right, you need to see why you're not getting them right. These ones are the values. Minus 6, this one. Anybody who's having problems? Okay, anybody who's still completing the table, let me know. Should I wait for somebody who's completing the table?
Yes, sir, yes.
Yeah, please
2 minutes.
complete the table by yourself, match the answers. Let me know if there are any queries. Let me know once you're done. It's a MMD question. This should give you the required confidence as we are moving on better. Most of you said you are comfortable with beam diagram and calculation of reactions. Now we are on making of the SF table. Imagine as if you are uncovering the beam from left to right, from one point to the other, to the other, to the other, and keep allowing for the changes. Imagine you are moving a paper to the right, uncovering the required part, and then filling up the SF table.
Yes, sir, complete.
Complete. Anybody else still doing, guys? Everybody's okay. Now let me change the question. Anybody has any doubts on SF table now, since it's complete? Anybody has any doubts? None? Okay. Please make the SF diagram now. That's the next step. And if that is made correctly, that means 1/2 of the question is done. Please look at the values. You have some minus values, you have some plus values. Accordingly, decide how much space you want to leave on top of x-axis, how much you want to leave on below the y-axis, x-axis. Accordingly, you need to take a decision. Okay. I will take it to the next sheet. That will be the best for me. Or rather, keep it like this and then screenshot leke jana padega. Let me take a screenshot. Okay. Okay, now I will make the SF diagram. I am sure some of you are making it. Be careful in joining them, how you want to join. Have your eye on the beam diagram when you're joining them, guys. I have minus 47 and plus 36. So that means I have to have enough space both below and above. So 10, 20, 30, 40, 50. 10, 20, 30, 40, and 50. Okay. 20, 30, 40, 50. 10, 20, 30, 40, 50. This is SF. Units will be kg, up and down. First we have A. Then we have 2 meters from A, we have X. Then 6 meters, so 6 meters from, okay, that will be a little too much, I think, okay. Now at 6 meters from X, we have C. And 2 into 4 meters, we have this y, and 4 meters, we have b. So 6, 4, and 4. Then we have 0. Then we have minus 14. And then we have plus 36. Okay. A to x is a straight line. Okay. Then it goes to plus 36. Somewhere here it goes like this. And it goes to minus 6. Minus 6. From minus 6 it goes to minus 19. Minus 19 it goes to minus 47. It goes to plus 28. And it becomes 0. Guys, please see if you agree with this diagram or if you made this. Unless you have messed up somewhere, let me know. All are straight lines, some vertical, some slanting.
Yes.
So only from minus 6 to minus 19.
Is vertical, na beta?
Yes, I made that slanting.
Okay. No. As long as you realize it, it's okay. It's okay. The whole idea of doing in steps is, if you have identified your mistake, you'll correct it. If you're still in doubt, then we discuss. Okay. Guys, anybody still in the process of drawing, please let me know. I'll wait for you, beta.
Yes, sir.
Please let me know once you're done. And if you have a doubt, let me know.
So done, sir.
Done. Anybody has any doubts about the SF diagram? If you don't have any doubts, then that means half of your question is done, beta. Half of your question is done. Now, let me first address one thing. He said, find the value of the SF 2.55 meters from end B. So look at the diagram. Will it be plus or minus 2.55 meters from end B? Is the shearing force going to be plus or minus?
Plus, sir.
We are talking of this value, yes or no? 2.55 meters from here, right?
Yes, sir. Plus.
Okay. Now, if you read from the graph, obviously there will be limitations of the scale, right? In such cases, you can calculate it. How will you calculate? It's a straight line, right? So from 28 to 0, it is happening over 4 meters length, you see. So over 4 meters length, the change is 28 units, 28 to 0 or 0 to 28, whatever you want to say. You say 0 to 28, it's changing over 4 meters. That is the distance from Y to B or B to Y. Every meter, it will change by 28 by 4. How much will it change from B over a distance of 2.55 meters? That means I multiply by 2.55. This will be the value of the shear. How much?
17.85.
17.85 kg will be the shearing force at a point 2.5 plus also please, plus 17.85 kg will be the shearing force at a point 2.55 meters from end B. Have you understood what have I said better and done?
Yes, sir.
Yes or no?
Yes, sir.
Yes, sir.
So any point on this graph, we can find out the value.
Yes, we can find
If
out
it
the
is
value.
given.
Why we cannot? Why we can
Yes,
find?
sir.
See, but if you read from the graph, see, I agree with if somebody says, sir, if I have to calculate everywhere, why should I draw the graph? Because one purpose of the graph is to use it for further reading. Yes or no?
Yes, sir.
But what will happen is if your scale is too small, then no way you can read it as 18.75. Either you'll read 20 or you'll read 15 or 16 or 19, something you'll read like this, correct?
Correct, sir.
You can't read it 18.7, but in such simple cases, since we can calculate straight away, it is better that you give them the exact value. Okay, beta? It is recommended. If you don't understand, then read from the graph and give, no problem. If they'll deduct some marks, it's okay. No problem. So one part of the question done, including the value at 2.55 meters from end B. Now, guys, now look at the graph and tell me, for BM table, are these 5 points good enough or is there any other point to be taken? Look at your diagram and tell me.
So one more point needed at the
Between X and
yes,
C, this point
yes,
you're
sir.
talking about.
Yeah.
Let me call it as Y. Let me call it as Y.
minus. Yeah. Yes.
Okay, guys. Now, firstly, do you all agree that for BM, the points, I'm writing here, BM, for points, BM will be A, X, Y, C. Actually, Y we already had, so let's call it Z. Sorry, my guys.
Yes, sir. Yeah.
Okay, we already have Y, so let's call it Z. So
Yeah,
A, X, Z, then C, then Y, and B. These
And
are the 6
D.
points for which we'll need to make the BM table, correct?
Yes.
Okay. Guys, to the left of Z is a triangle. To the right of Z is also a triangle, for which we'll need the base. That means we'll need X to Z and C to Z. Again, if you don't have time, then you can read from the graph. But then if you read from the graph, your BM at the end will not become 0 because of the reading errors. In such simple cases, it is again suggested that we calculate these values. We know X to C is 6 meters, that we know. Now we can calculate X to Z. How do we calculate, beta? Beta, from plus 36 to 0, how many units change is required? It is plus 36 at X, it is 0 at Z. How much change is required from plus 36 to Z? 36 units, yes or no?
Yes.
Correct?
Yes, sir.
And between X and C, how much is the change taking place? Look at the values and you tell me what is the change taking place from X to C? How many units change? X to C, what is the change taking place? It is taking
units.
place from plus 36 to minus 6. But not 30, it is 42 units, bete.
42
units. 42 units.
It's 42 units,
42
bete.
units. Yes,
Okay.
yes.
So we can calculate by unitary method again. And I'm using this space to explain because I want to this space for table and BM diagram. From X to C over 6 meters, you have 42 units changing. Now 42 units change over 6 meters. That means 1 unit changes over 6 upon 42. And if it has to become from 36 to 0, then how much will be the distance over which 36 units will change? So this is 7, this is, sorry, 6.
5.143.
0.86.
5.143, is it?
Yeah, 0.86.
Okay, that one will be point. Okay, fine. So basically then X to Z is 5.143. And
yes, sir.
CZ will be 6 minus this, so 7, 5, 8, 0.857 meters will be XZ. Understood, guys? CZ.
Yes, yes.
CZ will be 0.5, 0.857. Guys, have you understood this, what I've done? If anybody has any doubts, let me know. Because this will help me in getting the exact areas rather than approximate areas by reading from the graph.
So can you please explain once again this unitary method, what we have taken, 42 units?
You tell me, beta, how many units has the S shearing force changed from X to C? How many units is the total change?
36 plus 6, 42.
And over how much length?
That will be 6 meters.
So over 6 meters, it's 42 units. We want to know over how many meters will be 36 units? Because if it changes 36 units, it will come to 0. Yes or no?
Yes, sir. 2
So
point
we are
Z.
finding out over how much distance will it change by 36 units, right? So whatever we have to calculate, we keep on the right side. For 42 units, the change happened over 6 meters. For 1 unit, it will be 6 by 42. For 36 units, it will be 5.143, right?
Yeah, okay, sir. Okay. I got it now. Then
Okay.
C2Z. Okay, this is for
C2Z
1
is
unit.
6 minus this. 6 minus this.
Okay, thank you, sir. Thank you.
XC is 6, and you've got XZ. Now you can get ZC, yes or no, beta?
Yes, sir. I got it. Thank you, sir. Thank you so very much.
Okay, guys. Now I will make the BM table here, guys, for these points, or rather you make the BM table. I'm making it myself for my own sake. You please make for these 6 points now. Don't jumble up the sequence. Make sure you're putting them in the correct order, guys. Make sure you put them in the correct order. Unit of BM put here. I'm leaving it blank for you to put. Excuse me. What happened? I've made a mistake somewhere, it seems, is it? Of base into height.
The point why?
Yeah, I made a mistake, I think. Let me just check again. Let me check again. Yeah, because it's not becoming 0, so I already have this warning. 19 plus 47 divided by 2 into 4. 132 is minus, and we had 76. Okay, it's 55 point. Sorry, not 35. That was a writing error. 55.994, which is 56 basically. It becomes 0. 55.994 is 56. This is because of the rounding off of this 5.143, you know. Guys, once you complete, you can round off to 1 decimal place also, everything, no issues. Don't have to fight up to 3 decimal places. In the end, if there is some residual, which is rounding off issue, you can make it 0. Okay. So let me just put the values of my BM in red here so that everybody, those who want to compare, don't get confused with this table. It's 0 here, minus 14, plus 78.6, let me put it like this, plus 76, minus 56, and 0. These are the values of the pending moment, guys. Am I right?
Yes, sir.
If you've got these values, fantastic. That means you are good up to the BM table. Then you're just one step short. That is the diagram of the question. You're just one step short of the question then. Okay, anybody still making the table, completing the table, please speak out. I'll wait for you.
Yes, sir.
Okay, let me know as
Sir,
soon as done. Yes.
sir, this ZC,
ZC, yes, yes.
it doesn't make it, it's not making a proper triangle. So we can assume from
Why it's making a proper triangle? Why is it not making a proper triangle? This one, see, this is not a proper triangle. Let me change to blue and draw the triangle there. Why is it not a proper triangle, bete? It's a proper triangle. There is no assumption in that. This is the axis. This is up to -6, and this is this. Is this not a triangle, beta? Its height is -6. Its base is 0.857. Is it not a triangle? This angle is 90 here, no, beta?
yes, sir.
Okay.
So can you please tell us why how it came half into
Sorry.
the
It
y
is the
value?
area of the trapezium is the change, beta. This is the area.
Trapezium, yes, sir.
This is
Area
the
of
area.
the trapezium.
Half of the sum of the parallel side. Parallel side is one is 19, other is 47. Half of these two sides, sum of these two sides make it half.
Okay, sir. Okay, sir. I was
Multiplied
subtracting the
by
-6.
Yeah, it is
Okay.
minus only. So it will be minus, and you had 76 from earlier plus, so it becomes residual is minus 56. Yes or no? The
Yes,
trapezium
yes.
is minus. You're right. Up to
Yes,
C, have you got 70 plus 76 up to
yes,
C?
yes, sir. Yes,
Okay,
sir.
then continue after that.
Yes, sir. Completed.
Very good. Let the other, somebody else was doing, let him do. So we are very close to the final step of our question, beta. And this should give you the confidence that if you're knowing one step at a time and you know that step, then you can be reaching the end. Those who are calculating, as soon as you finish, please let me know so that we can go on to the BM diagram then, beta.
Done, sir.
Done. Okay. Now please make your BM diagram, all of you. I'll make mine. And if there is a problem, then we deal with it. I'll overlap a little bit here. Okay, no, never mind. That's why I'm using a different color. So if there is a slight overlap, it's okay. It is minus 56 and plus 78. So I have on both the sides. Okay, and then we have first A. We have B at what distance? 10 meters. Then we have center C. Then very close to center C, we have Z. Then out of this entire length of 16 meters, out of 8, we have 4 and 2. Somewhere here we have X. And midway between these two, I have Y. Then I get 76, 70, 80. Okay, so 10, 20, 30, 40, 50, 60. Okay, 10, 20, 30, 40, 50, 60. Okay, 10, 20, 30, 40, 50, 60, 70, 80. Okay, this SFBM will be in ton meter, guys. I had left the units here intentionally for you to fill up 10 meter. I hope you have done that. And now we have at A, it is 0. At X, it's minus 14. Minus 14. At Z, it is plus 78. Then it is plus 76, very close to it somewhere. Okay. And minus 56, 10, 20, 30, 40, 50, 56. And then 0.
Sir, BM unit will not be kg meter?
Oh, it is kg, is it? Okay. Sorry, my mistake. I took it as ton. It's kg. You're right. You're right. It's given in kg. No, okay. I thought I'm doing a ton question. Take a bit. Thank you. It's kg meter. Thank you. BM is kg meter, not ton meter. Sorry. I thought the weights are given in tons. My mistake. From A to X is a triangle from vertex to base. Then from X to Z is a triangle from base to vertex. This is also, of course, close by. You can't do much about it. The minus 56 is from base, vertex to base. So this will be, I'll go like this on the. Okay, and then it is base to vertex. Okay. Something like this will be the shape of the BM diagram, guys. Something like this.
Yes, sir.
Okay. Both the triangles at the end are from vertex to base. Then the next, the trapezium that has come is some combination of a rectangle and a triangle. So if you're doing from a smaller side to the bigger side, you can treat it like vertex to base. So somewhat like this would be your BM diagram. If anybody, once you draw it, if you have a doubt, let me know.
Sir, in BM diagram from Z to C, it should not come down, sir. थोड़ा नीचे नहीं आना चाहिए, sir.
आया होगा बेटा, वो they are so close to each other, Z to C, you can't make out. मतलब it will come down little bit, of course, when it is there. It will come down.
आपने
They are so close to each other, you can't do much about it, right?
Yes, sir.
Value is less, so
Sir,
it
ये
will come down. Obviously, it will come down better when the value is less, right?
Yes, sir. क्योंकि आपने
sir.
ठीक
Sir.
है.
हाँ बोलो.
सर ये 2.55 का वैल्यू बीएम में भी निकालना होगा?
निकालेंगे, अभी निकालेंगे. पहले let everybody be satisfied with the BM diagram बेटा. BM में भी निकालना है बेटा.
Okay.
So ये C2Y trapezium का ऐसे ही करना है randomly?
Randomly नहीं बेटा. You can treat it like a trapezium is what? A combination of a triangle and rectangle, ना?
Okay. तो फिर that's why Australia. Okay, understood.
Okay. Secondly, what happens is if the parallel sides, their height difference is not much, then it becomes more like a rectangle. If height difference is too much, it is closer to triangle, right? So accordingly, you can take a call how to shape it, right? But it's not randomly, it is basically governed by the triangle concept. Okay?
Okay, so okay.
Guys, is the diagram done? Can we then close out by 2.55 meter thing?
सर अगर हम इसमें डायरेक्टली y पे कोइंसाइड करा के कर देते C2y वाला
y पे कैसे कोइंसाइड करा लोगे बेटा? y पे से तो जाएगा तो फिर वर्टिकल लाइन होगा, वर्टिकल लाइन थोड़ी जाएगा ऊपर. वर्टिकल तो जब जाता जो when on top also the value would have been same.
Okay, so okay.
It will not go vertical, na? Vertical it would have gone only if it was basically the thing was at y. How can you have there will be only one BM at y? No, all BMs cannot be at y, correct?
Yes, sir, correct.
At BM there will be at y there will be only one BM, right?
Correct. Yes, I understood. Okay.
And BM is not constant from. So anyway, so that's your. Now, guys, anybody who's still doing the BM diagram, let me know.
It's okay, sir. Already.
So okay. Now, the last part is BM at 2.55 meters end. That means 2.55 meters from here. We are talking of this value. One is you can read from the graph. Again, there'll be a lot of errors. Second is you can look at the graph at this point, 2.55 meters from end B. Is the BM in the diagram negative or positive? Just tell me that.
Negative.
Negative. Oh, it is negative. And what is BM equal to? It's area under the curve. You can calculate this area, guys. This you already know is 17.85. Something you calculated. No, 17.85 you got, is it? SF here, you got 17.85. Am I right?
Yes, sir. 17.85.
Yes, sir. 17.85.
And area under the shearing force diagram will be BM. So this area will be the value of the BM. Now you'll say, sir, you are telling us minus, but it is plus. No, beta. If you are going from right to left, this will become negative. Understood?
Mm-hmm.
When you are coming from left to right, areas above the x-axis were positive, giving you positive BM, and the areas below the negative x-axis were giving you negative BM. But when you reverse the direction, then what will happen? Whatever is above the x-axis will give you negative BM. Yes or no?
Mm-hmm.
But if you're not getting it, don't worry. You can take the sign from here. Take the sign from here if you're having a problem. And you can calculate this value. Exact value of BM will be half into 2.55 into whatever SF you had got. What SF did you get? 17.85. Am I right?
Yes, sir. 17.85.
So when you multiply by this, that will be the value of the BM here. But when you read from here, of course, you can't read that accurately. But remember, this BM will be negative. Be very careful about it. Don't make a mistake. SF is plus 17.85. That is correct, because that is from the SF diagram, the sign is positive. But in the BM diagram, if you see, the BM at that point is negative, not positive. Okay, some of you may still be getting confused. Don't worry. Now, what? Okay, now I'll give you another way of doing it. I'll give you another way of doing it. Guys, if this is 2.55, how much is this going to be? 4 minus this? 1.45, yes or no? Correct? Correct, bete? Yes or no?
Sir.
Okay. What is
Yes,
the
sir.
BM at Y? Look at the table. What is the BM at Y? What is the BM at Y?
28.
Guys, what is the BM at Y?
Minus
In the
56.
table? Minus 56. And how much will be the change from Y to this point? That will be plus this B area, correct, beta?
सर आपका कर्सर नहीं समझ रहा है.
Guys, is this the problem, viewing problem with everybody?
Yes, sir. Yes, sir.
What is the problem?
Sir, cursor
What is
दिखाई नहीं दे रहा.
नहीं, cursor नहीं दिखाई दे रहा मतलब? Are you able to see that I have shaded the trapezium from Y to, in the SF diagram, I have shaded the trapezium, orange color, this one.
Yes, sir. Yes, sir. Yes, sir.
So
Golden
that
color.
is the cursor. That is the cursor, bete.
Okay, sir. So 1.45 and 2.55, the distance.
Yeah. So what I'm saying is 1.4, this trapezium, if this area you add to minus 56, will you get the BM at that point? Yes or no? Okay. Let me just again change my question. I thought you guys will catch it now, but never mind. It's okay. It happens sometimes. We get stuck. Never mind. Okay, now I'm taking the black marker. Let us say this point is the point where I want. Let this point be Papa P. Now I'm saying the way you calculated BM at all the points A, X, Z, C, Y. Now I want you to calculate BM at P. How will you calculate BM at P, beta? It will be BM at Y
area
plus the
yes,
area
sir.
of the trapezium. Yes or no?
Yes, sir. Yes.
Yes, sir. Sir.
Okay. What is BM at Y? BM at Y is minus 56, correct? What is the area of that trapezium? A, it is plus. 2, it is half into sum of the parallel sides. One side is 28, other side is 17.85, correct? Into the distance between the two sides is 1.45. If you calculate this, you will get a negative BM by automatically. That will be the BM 2.55 meters from end B. And the same you would have got had you got that chota triangle directly. What I'm trying to tell you is, the more you understand, more shortcuts you can take. I think this should be clear to you, how to get the BM at P. Yes or no, from left to right?
Yes, sir.
Okay, how much it comes to? 28 plus 28, this is plus beta, not minus. Again, I made a mistake. Okay, 28 plus 17.85 equals to divide by 2 multiplied by 1.45. This is plus, and we had minus of 56. It comes to minus
22.76.
0.76759 or 76. Okay, it comes to minus 22.759 kg meter. And you see the area. What is the area of this triangle coming, beta? Ye bhi calculate karo. Is it coming the same?
Same आ रहा है, same आ रहा है.
So that's what I was trying to tell you when I was trying to say take the area of the triangle, correct? So whichever way you have been able to understand, I have told you how to calculate the BM at a point which is 2.55 meters from end B. You can do it whichever way, but if you are doing with the triangle, be careful about the sign of BM. Don't answer as plus. That will be a mistake you'll make. So another way could be you pick up the approximate value from the BM graph and just change to exact value from triangle and keep the sign from the graph of the BM. Or you can calculate the way I've calculated BM at Y plus the area of the trapezium, that will give you BM at that point P. So whatever your way you've understood, both ways are equally good as long as you are able to close out. Now somebody may say, sir, if I'm not able to do any of the two things, an answer sheet is being snatched. Suppose I don't have time, I've drawn the BM diagram and now my answer sheet is being snatched. Then please come to the graph, go 2.55 meters from here, read of this value and read in the answer. From the BM diagram, BM at 2.55 meters from end B is minus, you may get minus 20, you may get minus 25. That is the error that will happen. If you get minus 20, write minus 20 kg meter. If you get minus 25, write minus 25 kg meter, but don't leave the question unattempted. Am I clear, Vita? Understood? Have you understood, guys? That if simple cases, if you can calculate and give exact answers, time permitting, that is preferred and recommended. But if you have your back against the wall and you're not able to solve, or you do not know how to solve, one day you got confused and you can't know, then please give the answers from the graph. Okay, beta, whatever best you can give. And write that your answers are from the diagram. Okay, beta? Have you understood what am I saying? Yes. I have said if you can calculate, fantastic. If not, say BM at a distance 2.55 meters from end B from the BM diagram is equal to so many kg meter, plus minus whatever answer from the graph you read, just give that answer. No issues. At least you'll fetch some marks, if not full marks. Guys, does this question give you some comfort about how to handle the question in steps, starting with the beam diagram, then getting the reactions, then identifying the points for SF, then making the SF table, then drawing the SF diagram, then picking up the points for BM table, making the BM table, making the BM diagram, and if any answers are to be put, they can be put. I'll send you some questions now. This question will come to you. Now this question, but I'll close it for the day. But like this question, can you multiply 61.162 by 9.81 and tell me how much will it come? How much it comes to?
$604.492.
So this you make 600 newtons, beta. Okay. That is what I was trying to say. Okay. 30.581 multiplied by 9.81 convert into Newton. A question like this, instead of dealing in kgs, you can convert to Newton. If it was in tons, you'll convert to kilonewtons. Understood? This is MMD August 21. So I would request you to do this question. I'll send you this question, don't worry. Then do this question also, try this. And then I'll continue with this tomorrow. No problem. Okay, I think, never mind, whatever it is. We'll continue tomorrow because we should do 2-3 questions in the class together to iron out the problems. So I'll take them, continue tomorrow for at least half a session till about from 9:30 to about 11. I'll continue with the beam. And from 11 o'clock, I'll quietly slip onto box-shaped vessel, beta. We'll quietly slip onto box-shaped vessel. Okay. And
Sir,
God
can you send me
willing,
this all this beam question together, sir? Set of beam question.
beta beam question I'm just sending you right away. Beam questions are there. But only do the ones which you can do. Don't unnecessarily.
Yes, sir. Yes, sir. Yes, sir. I will practice.
Let me just send you right away. And that's done for the day, guys. It's okay. No issues then. We'll connect at 9:30 tomorrow, and I think we are on target. I'm not too much worried about the timelines. We are reasonably in time, so don't worry about the time issue. These are the questions. Quite a few of them, 1, 2, 3 of them are from MMD, 4 of them are from MMD. In fact, 1, 2, 3, 4, 5, 6 of them are from MMD beta. Out of 8.
आपने सर एक क्वेश्चन था सर थोड़ा हटके एमवी हिंडशिप के भी आपने सर पास्ट क्वेश्चन भेजे थे जो कि फेज 1 और सेकंड मेट लेवल से हैं तो सर जो फेज 2 लेवल के अभी आपके पास अगर जो कोई क्वेश्चन मतलब सेट हो तो
अरे वो फेज 2 के पेपर से तो भेजे थे बेटे
नहीं उसमें लिखा हुआ था कि फेज रिलेटेड टू फेज 1 ऐसे करके
नो आई सेड अरे तो फेज 2 से शेयर किया तो तुम्हारे लिए थे ना वो
ओके सर ओके मतलब ये ऐसे ही आते हैं
I said those questions are based on what you already have done.
Okay, sir.
So that is what you should have started revising. अभी तो 3 दिन पहले तो तुम अभी पूछ ही रहे हो वो हमारे में है या नहीं है. शाबाश, very good.
नहीं सर मैं कह रहा हूँ अगर जो आपके पास ये तो कर लिए सर मैं उसका अलग से कह रहा हूँ और कुछ हिंडशिप का क्वेश्चन सेट था वो भी भेज दें सर.
बेटा वही तो था भेजा था ना मैंने पास्ट पेपर से निकाल के तुम्हें. I sent you that ना.
ठीक है सर ठीक है बस इतना ही काफी है बस इतना था. थैंक यू सर.
बस हाँ इतना कर लो इतना. हैं?
आंसर्स हैं क्या सर आपके पास मैच करने?
नहीं बेटा मैंने तो I just took out that from the papers बेटा. I didn't solve them. If you have any doubts, I can see you through the procedure of any question which is causing you concern. Okay. Okay, guys. Then I'll take your leave. I think it's 12:55. Chalo. Thanks a lot. See you tomorrow 9:30, guys. Then. Thanks.
Okay, sir. Thank you.
Bye, beta.